Hello, in lesson 5.3, parallel lines and proportional parts, you're going to use the triangle proportionality theorem to set up and solve equations. Now, the triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other side, then it divides the sides into segments of proportional lengths. So for example, right here, notice this line intersects the triangle and is parallel to this bottom base there. If this is happening, then, so as you see right here, DE is parallel to AC. So if this is true, then we create two proportional sides. That if I get the side of BD and divide it by the distance from D to A, that's going to equal to dividing the distance from this vertex to this point here to this side over the distance from E to C. And using that proportion, we can figure out missing sides. Now, the converse to this triangle proportionality theorem states that if we know that we have these proportional values, that if BD is equal to BD over DA is equal to EB or BE, let me write it the same way, BE over EC, then we know that those two lines, again, the lines that are connecting D to E and A to C, those are going to be parallel. And the reason that that's helpful is because then we know that this angle and this angle are the same, just like angle E and angle C are going to be the same. So that's why this is helpful, because if we know that these are proportional and we know this is parallel, then that just simply tells us that the angle A is equal to the measurement of angle D, which means they're congruent, just like angle E is going to be congruent to the angle C. So using that idea, we're going to figure out some missing links. So let's start by first figuring out on this example the value of x. Now, on the diagram, they're telling us that these two lines are parallel, as indicated by this marker here on both segments. So that means that if I get this distance right here to this segment right there, and I divide it by this segment right there, so if I get 14 and I divide it by 12, so here to there, that's going to be proportional to getting x and dividing it by 15, going from here to there, getting the longer side and dividing it by the shorter side on both sides, getting the longer segment and dividing it by the shorter segment on the top side here is the same thing as getting this longer segment and dividing it by the shorter segment on this opposite side. So here, cross multiplying, which is simply going to multiply 15 and 14 and dividing it by 12, that's going to give us a total of 17.5. So that's your answer. That's the value of x. So let's do a couple more examples. Same situation again, same idea. Key thing is understanding again that we have that these two segments are parallel, indicated by that marker there. So that means that if I look at this side here and I divide, in this situation I'm going to divide the shorter end, 18, and I divide it by the longer segment of x, that's going to equal to doing the same thing on the opposite side. getting the shorter end, 21, and dividing it by the longer end of 56. That's going to multiply the 18 and the 56 and divide it by 21. Sorry, which gives us that the value of x is equal to 48. Now, had I decided to divide the other way, had I decided to divide the x by the 18, the longer side, the longer segment divided by the shorter segment on this side up here, on this top side, x divided by 18, I would just simply have to do it the same thing on the other side. Get the longer segment of 56 and divide it by the shorter segment of 21 on the opposite side. I have to keep that proportionality again. So I cannot, and that's going to give me the same thing. X is still going to multiply. As you see, I still multiply by the 18 and the 56, and I'm going to divide by the 41. I still end up with the same answer of 48. So you see, I could do it either way. The one thing I cannot do is this. This is not going to be correct. Because notice that on that situation, I'm dividing x by the 18, so the longer segment divided by the shorter segment on this top side here is not the same thing as dividing the shorter segment by the longer segment on the opposite side. I have to keep it consistent, again, proportional. So this is not going to be correct. That's not the way we do it. So on number 3, I want to do the same thing. In order to figure out the value of x, looking at the left side right here, I can either divide the longer segment by the shorter one or vice versa, the shorter divided by the longer. I'm going to do this time, since I'm looking for x, I'm going to do the shorter side and divide it by the longer segment. The longer segment divided by the shorter segment, there we go. The shorter segment divided by the longer segment. Okay, so I'm going to get x and divided by 36. Now on the other side, on this side right here, I do not know the length of the smaller segment. I know that the longer segment is 45, but the shorter segment is not given. What we're given instead is the length of the entire opposite side, which is 55. Well, then that means that this side would just simply have to be 10, because 55 minus 45, that's equal to 10. That's equal to 10. So we know that this segment right there has to be 10. So getting this shorter segment of 10 and dividing by the longer segment on this blue side is going to be proportional to x divided by 36. And now multiplying 36 times 10, which is 360, and dividing it by 45 gives us our answer of 8. So we're going to cross multiply. So we multiply 36 and 10, which means we're going to end up dividing by 45. So x is going to equal to 8. Now, for number 4, same situation. Notice that we're looking for the value of x. So we have this diagonal side. I'm going to highlight in yellow. And I'm going to do the same thing. I'm going to get the value of x, which is the longer segment, and divide it by the shorter segment. So x is going to be divided by 7. That's going to equal to, so x divided by 7. That's going to equal to getting the other side, let me highlight in blue, and doing the same thing. Getting the longer segment on this blue side and dividing it by the shorter segment on that blue side. And again, since the entire segment, the blue segment measures 27, that means that this segment here is going to be 21, since 27 minus 6 is equal to 21. So we're going to get 21 and divided by 6. That cross multiplies 21 with 7, and dividing that by 6 gives us an answer of 24.5. So x is equal to 24.5. All right, so moving on. Moving on to the next example. Now here, we want to set up the proportion the same way, but notice again now that we have not just only an x, but an x plus 7. But we set up the proportion the exact same way. So starting on the left side, this side right here, I'm going to look at the smaller segment. I'm going to get the smaller segment of x plus 7 and divided by 30. So x plus 7 divided by 30. That's going to be proportional to doing the same thing on the opposite side and getting 15 and dividing it by 25. Now here, because of the plus 7, this is going to ruin again our strategy of simply cross multiplying and dividing, because here we're going to have to multiply both the x and the 7 by 25. So we're multiplying 25 with x plus 7, and we're multiplying 30 with 15. So on the left, in order to multiply 25 with x plus 7, that's going to require distribution. So that's going to give us 25x. Well, you know what? Let me do something else. Before we actually cross multiply here, let me do something else. Something that we did on the other one. So let me erase all of this and let me go back. I see that here in this fraction, I have a common factor of 5. So if I divide both of these numbers by 5, this becomes 3, and this becomes 5. So instead of using 15 and 25, I'm going to use the reduced form of that fraction, which is 3 over 5. So I'm going to cross multiply and multiply with 5, and multiply 30 by 3. That way my numbers are not too big. I still then distribute, and now my numbers are not as big as they would have been had I multiplied by 25 and 15. So here I would start by subtracting and moving the 35 to the other side, making it negative 35, and adding it with 90. And that's going to give us a total of 55. So 5x is equal to 55. And dividing by 5, we get that the value of x is equal to 11. And there's your value for x. Let's see another example similar to that. Here again, and I haven't gone over it, like we've been taking it for granted again that these things are are parallel. So we have to verify that these things are parallel. It doesn't work unless these two segments are parallel to each other. And because they are, that means I can create a proportion by dividing the two segments on the left and the two segments on the right. So I'm going to divide the longer segment of 21 by 6. So 21 divided by 6. And that's going to equal to doing the same thing on the right side, getting the longer segment of 3x plus 1 and dividing it by the shorter segment of x minus 1. Now 21 and 6, they have a common factor also. They both can be divided by 3. So if I divide both of these numbers by 3, this becomes a 7. And this becomes 2. So instead of cross multiplying with these larger numbers, I'm going to multiply by 7 and 2. You know what? Let me write them over here instead. 7 and 2. So here cross multiplying, we're going to multiply 7 with x minus 1 equals to 2 times 3x plus 1. That just makes it a little bit easier, so we're not using such big numbers. If you don't want to cross reduce that and you want to use 21 and 6, you can. But I just want to simplify and just not use such big numbers. So distributing 7 into the parentheses on the left, this gives us 7x minus 1. And distributing the 2 into the parentheses on the right side of the equation gives us 6x plus 2. Now with letters to the left and numbers to the right, we're going to get 1x is equal to 9. And dividing 9 by 1 is going to just simply give us 9. So this is the value of x. X is equal to 9. Now, applying the triangle proportionality theorem, in order to verify that this line here is parallel to this line here, we need this proportionality to be true. So if I look at the left side and I divide the smaller segment of 11 by the larger segment of 15.4, that should equal to the same thing if done on the right. Dividing the shorter segment of 10 by the longer segment of 14 should equal to a proportional relationship. And the way that we verify this is by cross multiplying. So if I multiply 11 with 14, that's equal to a total of 154. And if I multiply 15.4 with 10, that is also equal to 154. So as a result, because this is true, that this proportion is true, what that means is that this segment from point M to point N is parallel to the segment from point J to point L. So these two segments are in fact parallel to each other, which implies something else. That implies that the angle of M is congruent to angle J, and angle N is congruent to angle L. So there you go. Let's do one more example like that. Let's apply the triangle proportionality theorem. So let's see here. Let's verify if these two segments, again, MN and JL, are going to be proportional. So if I look at the top segment and I divide the longer side by the shorter side, so if I do 15 and I divide it by 4, that should be proportional, and that should equal to the same thing as doing the same thing on the other side, on this bottom side here. So if I get the longer side of 18 and divide it by 5, that should be proportional. Those two things should be equal to each other. So let's check. Let's multiply 15 times 5. That's equal to a total of 75. And let's multiply 18 times 4, which is equal to 72. Since these two things are not equal to each other, this means that this is not true. This is false, that these two fractions, ratios, are not going to be proportional. So that means that the segment from M to N is not parallel to the segment JL. So those are not parallel, which means that the angle M is not congruent to angle J, and angle N is not congruent to angle L. So there you go. Now this concludes the lesson, the notes on 5.3, the proportionality theorem. If you do have any questions, send me a message or a reminder or through email. Again, thank you for watching, and I hope you have a great day.